Okay, this is Math 1325. Going to be working the day 2 review. We've got 5 word problems here. So the first problem is cost analysis. Talks about a taco bar that has a fixed cost of $150 per day. $150. And then a variable cost of $0.15, which is 15 cents per taco. All right. It says find the total daily cost of producing X tacos. So your formula for this is that the cost is going to be the fixed cost plus the variable cost times X. So we're going to have our cost is equal to $150 plus 15 cents per taco. So per taco means times X. X is the number of tacos. So think about this company is got a certain amount of cost to run their business. No matter what, they got to fire up the grill, whatever. It's going to be $150 per day to run the, let's say it's a taco, what are those trucks that drive around? $150 no matter what. But then it costs them 15 cents to actually make each taco. So it's 15 cents times X. That's going to be our equation that we're going to be using for this problem. And then part A says how many tacos can be produced for a total daily cost of $450. So they're saying what if how many tacos, X is how many tacos. They want to know how many tacos can we make if the total cost is going to be $450. So all we're going to do is take that equation, we're going to replace C with 450, and that equals 150 plus 0.15x, and we're going to solve this for x. And this is just a linear equation, so we'll subtract 150 from both sides. That'll give us 300 over here, equals 0.15x. So now you could get your calculator out or do this math in your head, whatever. We got 2,000. Make sure I did that. Yeah, 2,000. So if I divide both sides by 0.15 so that I can get x by itself over here, divide this by 0.15, we get 2,000 equals x. So if my daily cost is $450, that means that I made 2,000 tacos. That's a lot of tacos. All right, that's part B. Part B says if you produce 5,000 tacos, so if X is the number of tacos, if X is 5,000, what will the cost be? So the difference in this problem is that we're going to replace this with 5,000 and figure out what cost is. So that means cost will be 150 plus 0.15 times 5,000. So we'll go ahead and multiply 5,000 times 0.15, and that gives us this right here multiplied to 750. So we have 150 plus 750, that's 900. So it should be $900 to make 5,000 tacos. All right, that's the first problem. The second problem has to do with a markup policy for marking up drugs at a drugstore. So a drugstore sells a drug costing $55, and they sell it for $120. And then another drug that costs $125, and they sell it for $175. So this is the wholesale price. Then they mark up Okay, they mark it up to the retail price. That's how much the customer is going to pay. This is how much the company pays for it, the drugstore pays for this much for this drug, and then they mark it up to 120. They buy it for this much, and they mark it up to 175. It says, if the markup policy of the drugstore is assumed to be linear, write an equation that expresses the retail price R in terms of cost. So we want our retail price to be some function of the wholesale price, which is C. So this is some function, right? Retail, it's kind of like when we write f of x equals something. We're going to say R is the name of the function, and R, the retail price is a function of the wholesale cost or wholesale price. So this is R, and this is C. So think about this linear, and visually what's happening is this. We have the wholesale cost and the retail cost. If we bought the drug for $55, then sold it for $120, you could look at that as an ordered pair. It's the ordered pair 55, 120. And then if we bought the drug for $125, a different drug, and marked it up to $175, this is another point, and we can look at it as an ordered pair. $125 is the wholesale cost, and then the retail cost that we sell it for is that. We're assuming that this is linear, so that there's a line connecting these two. And of course, we'll have to stop it here because we're not going to have negative cost. And this is our linear function. We're trying to figure out what is that linear function. So this just breaks down to how do you find the equation of a line between 2 points. So the way we do this is we can use the good old, there's a good old formula that we have for this. The equation of a line is y minus y1 equals m times x minus x1. Remember that? This is called your point slope formula for a line. So in order to come up with the equation of a line, you need a point on the line and the slope of the line. We actually have 2 points, so we could use either one of these. Why don't I use this one? I'll call this x1, y1. And then we need the slope of the line. And to find the slope of the line, what we do is we find we can look at a little triangle here. We're going to go over and up, but when we do slope, we do rise over run. So this is our rise, okay, and then in this case our run is this way. So we want to know our slope, m, that's what we use for slope, is rise divided by run. And there was a formula for this. It was y2 minus y1 over x2 minus x1. It's the difference of the y coordinates divided by the difference of the x coordinates. Now I need to label this point. Let's call this x2, y2, and let's just figure out what this is. So y2 is 175 minus y1 is 120 over x2, which is 125, minus x1, which is 55. So 175 minus 120, what's that, 55 over, and then what's that, 2070? Okay, so 55 over 70, and we can reduce that fraction, just make sure my math is right there, 55. We can reduce that fraction. Let's see, 5 goes into each of these. 5 goes into that 11 times. And 5 goes into 70 14 times. Yeah, 50 and 20, yeah. So 11 14ths, that's our slope. So going back and using this equation right here, we know that y minus y1, which we said was 120, equals slope m, 11 over 14, and then x minus x1, which was 55. So this is how we would find the equation of the line if it weren't this word problem. This is how we would find the equation of the line between these 2 points. Now, what I'm going to do at this point is I'm going to replace x and y with what they are in our situation. Remember, the x here for us is c, and the y is the r. So I'm going to replace this y with r, minus 120 equals 11 over 14, and then x was c, so c minus 55. And we almost have our linear equation. We almost have what this function r is. All I need to do is get this 120 to the other side. So I'm going to add 120 here, add 120 here. And so what we get is r is equal to 11/14 c minus 55, and then I added 120 to both sides. And that is the equation that connects the retail price to the wholesale price. Give me the wholesale price, I can give you the retail, I keep on saying resale, retail price. All right, so I believe that's what we wanted for the first part here. Write the equation that expresses it. So that's part A. Okay, so part B says, what does a store pay to the nearest dollar for a drug that retails for $225? So if the drug is going to retail, if the retail price is going to be $225, then what is the cost of that drug when they buy it wholesale? So let's go ahead and replace R with 225 here. Equals 11/14 C minus 55 plus 120. So what I'll do now is I will subtract 120 from both sides. I'm going to try and solve for C. So that's gone. And then this right here, what do you get here? 105 equals 11/14 C minus 55. Okay, this is going to get a little weird now. We're going to get some decimals. I'm not going to distribute this through. I could, but what I'm going to do instead is I'm going to multiply both sides of this equation by the reciprocal. I'm going to go multiply by 14 over 11 here and multiply this side by 14 over 11. And so what happens here is the 14s and 11s cancel, and basically the right side of this equation now is just C minus 55, which is nice. Over here, I have to do 14 divided by 11 on my calculator, which gives me like 1.272727, and then multiply that times 105, and I get about 133.636. I'll just stop there. That's good enough, because they want us to round to the nearest round. Do they say round? Oh, to the nearest dollar. Okay, so yeah, that's plenty of rounding here. And now what I'll do is I'll add 55 to both sides. So plus 55, and that's 186. So what we get on the left side is 188.636 equals C. And if I round that to the nearest dollar, it's going to be about $189. So if the drug is going to retail for $225, then that means that the wholesale cost of that drug was $189. If we are using this is our linear model. Okay, that's number 2. Let's move on to number 3. Number 3, find the profit function if the revenue function is, am I recording? Yes, okay. Find the profit function if the revenue function is given by x times 2,000 minus 60x, and the cost function is given by 4,000 plus 500x. And they want us to find the profit function. So what is the profit function? That's what they want to know. Okay, so let's see what I got here. Freeze warning. We're supposed to get a freeze? I did not know that. Okay, what is profit? So profit, if you don't remember, profit is revenue minus cost. So we need to remember that. It's how much money you bring in minus how much it costs you to run your business. So what we need to do is take those two, take this and subtract this. Now before I do that, I'm actually going to distribute that x through the parentheses. So that's 2000x minus 60x squared. And I could write it like that. I could also change it if I wanted to. There's nothing wrong with leaving it like this, but I could switch the order like that. And that's what we call descending order. It's the highest power of x down. I'm going to write it that way. And now when I come here to the profit function, I'm going to write my revenue function this way, negative 60x squared plus 2000x. And then I'm going to subtract my cost. So subtract, now here's your cost. It has two terms. So when I subtract the cost, I need parentheses, 4,000 plus 500x. And now distribute the minus through. So you should get negative 60x squared plus 2000x minus 4,000 minus 500x. So the negative turned both of these to negatives. And now let's collect like terms. So we have negative 60x squared, and then I have 2000x minus 500x, which is going to be 1500x minus 4,000. Or yeah, minus 4,000. So I was only able to combine these two together. So this right here is going to be my profit function, which is what they wanted you to find initially. Then it says, find the break-even points. So what are the break-even points? Break-even, you can look at break-even points two different ways. Break-even point is when your revenue equals your cost. That would be when you break even. But that is the same as saying that revenue minus cost. So if I were to subtract cost from both sides of this equation, it would go away here and it would come over here as a minus cost. And then on this side, we would have 0, right? So it's break even is when revenue equals cost, or when revenue minus cost is 0. But revenue minus cost is actually the definition of profit. So this is still saying, this is actually saying when is profit 0. So what I'm getting at is that there are two different ways to look at break even. You can set revenue equal to cost, or you can set your profit function equal to 0. Either of these will give you the same result. So what I'm going to do is I'm going to take our profit function, which we already have right here, and set it equal to 0 and solve it. So when I take my profit function, okay, my profit function is negative 60x squared plus 1500x minus 4,000, and I set it equal to 0, I then go about trying to solve this equation. All right, this is going to give me my break-even points. So let me first try and find a GCF, because I could use a quadratic formula, which I'm probably going to use, I don't know yet. But even if I use a quadratic formula, these numbers are really big, and I noticed that I can at least get 10 into each of these. So maybe 60 goes into each of those? No, okay. Maybe 20 goes into each of those? Yeah. Yeah, 20 goes into each of these. So watch what I'm going to do. I'm actually going to factor out a negative 20, because I do not like a negative on that first term. And then let's see what we would have left. Negative 20, I'd have to multiply by 3 to get that, okay? And then on my calculator, I figured out that this already is going to be, I'll need a negative, because negative times negative is positive. I'll need 75 here, x. And then negative 20 times what up here? We need a positive, 200 equals 0. So I just factored a negative 20 out of each of those. And then at this point, I can divide both sides by negative 20. And this is gone. and all I have is 3x squared minus 75x plus 200 equals 0 divided by a number like that, negative 20 is still 0, so we get that. That's just an easier quadratic equation to work with, and the solutions to this equation are identical to the solutions to this equation. So we don't have to worry, that negative 20 doesn't affect your answers. Now, at this point, quadratic formula, I don't feel like trying to factor that. I don't think I'm going to be able to factor that easily mentally. So I'm not saying can't be done. I'm just kind of going to throw in the white towel on that one already. So I'm going to go negative b, which is 75, plus or minus the square root of, so I did negative b. B for us was negative 75. Now here's b squared, so I have to do negative 75 squared. And remember, that's always going to be a positive number. 5625 minus now 4 times a, which is 3, times c, which is 200, and that's going to be 2400. So I'm going to subtract 2400. I'm going to divide all of that by 2 times a, 2 times 3, which is 6. So I'm trusting you remember the quadratic formula from just a little while ago, or from the previous exercises. And now square root of, let's see, 5625 minus 2400 is 3225 all over 6. And now on my calculator, I'm actually going to take the square root of that. And when I take the square root of that, I get x is equal to 75 plus or minus, I'm getting about 56.79, I'm going to round that 2 decimal places, over 6. So square root of that is this. And now I've got my 2 little cases to look at, my 2 roads to follow here, the plus and the minus. So if I add, I'm going to do 75 plus 56.79 and divide by 6. And then on the bottom one, I'll do 75 minus 56.79 and then divide that by 6. Okay, so let me get those 2 answers. Plus 75, divide by 6. So one answer I get from this one on top here is that x must be 21.96. Or now if I do this one, 75 minus 56.79 is 18.21 divided by 6. I get 3.035. All right, we should be good to go there. Let me see, I'm just check it real quick. Plus 1500. I apologize for taking the time to check this, but just want to be sure that I've got the right answers here since I'm doing this on a video. 0, 5. Yep, okay, and then just double check the last one. Yep, okay, we're good to go. So the break-even points are these 2 right here. Now we don't know what x is because this problem wasn't, we weren't told what it was, but maybe x is the number of cupcakes you have to sell in order to, you have a profit function, you have a revenue function for the number of cupcakes you sell, you have a cost function for the number of cupcakes you sell, and then you could find your profit function, and then we found that at about 22 cupcakes you break even, about 3 cupcakes you break even. So the profit function broke even at somewhere around 3 and like 22, and our profit function was a parabola. It was at negative 60x squared, so we know that it opens down. So our profit function looked something like this, P. And we know that we broke even, had no profit here, no profit here. But that would mean if we sell anywhere between 3 and 22 cupcakes, we should have a positive profit. All right, number 4 has to do with boiling points. The temperature at which water starts to boil is also linearly related to barometric pressure. Water boils at 212 degrees Fahrenheit at sea level, 212 degrees Fahrenheit at sea level. Sea level, we're going to call 0 feet, okay? And then it also boils at 193.6 degrees at an altitude of 10,000 feet. Okay, so if you're higher up in elevation, the boiling point of water is lower than at sea level. At sea level, the boiling point is 212 degrees. So this is a linearly dependent relationship. So what they want here is find a relationship of the form T equals mx plus b. So that's the equation of a line where T is the degrees in Fahrenheit. So this is going to be our temperature axis right here. And x is the altitude. So x is altitude. I'm just going to put alt. And T is temperature. This is going to be in Fahrenheit, degrees Fahrenheit. All right, so what we know is we have to take this information here and plot 2 points so we can get a visual idea of what's going on. The altitude is measured in feet. So at 0 feet, that's this way, 0's right here, our boiling point is 212 degrees at 0. And then at 10,000 feet, which we'll put out here, our boiling point has come down to 193.6 degrees. So we have 2 points, there they are, 2 points. And we have a linear relationship like this. So with that in mind, we can assume that there's a line between the two, and what we need to figure out is that same thing we did earlier. We can use that point slope formula of a line, which says y minus y1 equals m times x minus x1. Or, because we actually know the y-intercept, right? This is the y-intercept. We know that 212 is the b. So this is a different form of the line. It looks like this, y equals mx plus b. This formula is very convenient when you know the y-intercept, because that's what this is. In this particular problem, we know it. Had this point been over here somewhere, we would need to go back and do what we did on what, problem number 1? Oh yeah, by the way, what problem was this? This is problem number 4. So I'm going to take advantage of that, and I'm going to take advantage of the fact that I already know that that's 212 degrees. So all we really need to know is the slope. And to find the slope, you just need to find rise over run. So this point right here is the point 0 to 12. This point is the point 10,000, and then 193.6, right? So keep in mind, the x-axis is the feet, so that's why this is 0 and 10,000. And then the y-axis is the temperature, that's why these two are these two values. Don't mix those up, because the way we have it drawn and the way they want it, that's the relationship we have. So rise over run, we would have to still use our formula m equals y2 minus y1 over x2 minus x1. We'll call this x1, y1. We'll call this x2, y2. And now we're going to need a calculator here. So if we take y2 and subtract y1, so 193.6 minus 212, we're going to get for the top negative 18.4. And on the bottom, we're going to take x2 minus x1, that's going to be 10,000. And if I divide that, I get negative 0.00184. That's our slope. So we're ready to have the answer here. RT, our temperature, is going to be equal to negative 0.00184 x plus b, which was our y-intercept, which was 212 degrees. So that's it. That's what we're looking for on this problem. Find the relationship. Now we've got the relationship. I'm going to box this up. And let's go on and answer part B. This was part A. Part B says, find the boiling point at an altitude of 5,500 feet. So for part B, so find the boiling point. The boiling point is the temperature. Find that if the altitude is x, right? If that x value is, what did they say, 5,500 feet? 5,500 feet. So I'm just going to go into my formula, t equals negative 0.00184, and then x, which is 5,500, and then I'm going to add 212 to that. And that will be our boiling point at that altitude. So I'm going to just do this. If you multiply these two together, right there, you should get temperature equals negative 9.2, and then plus 212. And you get 202.8 degrees Fahrenheit, right? All right, so at an altitude of 0, the boiling point is 212. If I go out to a higher altitude, the boiling point should come down. If we go to 5,500 feet, our boiling point happens to be 202.8 degrees. All right, that's number 4. Last one, number 5. Supply and demand. At the price of $9 per box of oranges, the supply is 320,000 boxes and the demand is 200,000 boxes. At a price of $8.50 per box of oranges, the supply is 270,000 boxes and demand is 300,000 boxes. So let me just kind of summarize what's going on. We have two prices, right? We have $9 and we have $8.50. Those are the two prices that we could sell this box of oranges at. In the case of $9, our supply at this price of $9, our supply is 320,000 boxes, and the demand would be 200,000. Okay? If we change the price to $8.50, then the supply drops and the demand is going to go up because they're cheaper, right? All right. So that's a summary of what we've got here. It says find the price supply equation, this is part A. Find the price supply equation of the form P equals mx plus b, where P is the price and x is the corresponding supply in thousands of boxes. All right, so that's an important little catch. That x is going to be the supply in thousands of boxes. So what we're talking about here is, since we're talking about price supply equation, we're going to be talking about just this information right here. Okay, so there's a line that tells me about how the price and supply is related. So graphically, if x is my supply in thousands, and this y-axis is P is the price, then what do I know? At $9, my supply is 320,000, right? So the way I can look at that, supply is this axis, right? So if supply is 320,000, which really turns into 320. So if my supply is 320, which we're measuring in thousands, so that's 320,000, then my price should be $9. Okay, that's that first piece of information. This second piece of information says if the supply is 270,000, then the price is, that's what happens at a price of $8.50. That's this point. And we're assuming that this is linear, so there's a line going through these. Same story that we had just a little while ago, right? So we have a point here. This is the point, be careful, it's 270, 8.5. And this is the point 320, 9. And so what we're going to need to do is find M and B. Now, unfortunately, we don't know the y-intercept, so we can't just get B right off the bat. So we've got to go back to this good old friend of ours, y minus y1 equals M times x minus x1. And why don't we call this x1, y1, x2, y2. And let's plug things in, and let's find our m. Let's get our m right now. Our m is y2 minus y1 equals x2 minus x1, which is y2 minus y1, 9 minus 8.5 over x2 minus x1, 320 minus 270. Okay, so I'm going to go ahead and get that on my calculator. Ooh. This is going to come out to be 0.01. That's our slope. Okay, so I did all this on my calculator, I got 0.01. And now I come back over here. All right, y minus y1 is 8.5 equals m, which is 0.01, and then x minus 270. So that is my linear equation that describes this line. Let me replace some variables. My y is actually this axis, so that's p. So p minus 8.5 equals 0.01, and then my x, they wanted us to use x, okay? It says it in there, so I'm going to put x minus 270. And that's a good equation, but they want it to look like this, right? Oh, there it was, sorry, I was looking for it, there it is. They want it to look like that, so we're not quite there. What we need to do is, let's distribute this through here. So we get p equals, or sorry, p minus 8.5 equals 0.01x, that's what happens when I multiply this times this, and then 0.01 times 270 should be minus 2.7. And then now we add 8.5 to both sides. Okay, so p equals 0.01x, and then I need my calculator for that. That's pretty pathetic. It's 5.2. My brain just doesn't work. 5.8. There we go. I just want to make sure I'm right on. I don't want to make a stupid mistake. Okay, so there we go. We've got, this is our price supply. Equation. Then you have, in the next part B, they want the price demand equation. To do the price demand equation, we're going to do the same thing, but we're going to use this information instead of this. We're not doing this anymore. So now we can draw another picture. It's going to be a totally different line. So we know that I'm going to go a little faster through this, at 200,000, price 9, and we know at 300,000, so 300 here, that's what's happening at 850. So as points, this is the point 209, and this is the point 300, 8.5. And then we go through the same process. I know I'm going fast here. Call this x1, y1, x2, y2. And then we need to find the slope. We need to find the slope, and we need to plug into that formula over there. So m is y2 minus y1. So if you do 8.5 minus 9, that's going to give you negative 0.5. And then if you go 300 minus 200, you get 100. So we're going to get negative, oops, I forgot my negative. Negative 0.005 is what we get. So if you divide by 1, it's the same thing, right? If you divide by 10, it's going to get smaller. It's going to move the decimal over one time. If you divide by 100, it moves it over twice. So that's just taking that and moving it twice. All right, that's our slope. And now I'm going to come back and just use this right here again. And I've got my other one. This is my price supply. I don't want to erase that. This is going to become y minus y1 for us is 9 equals the slope, which is negative 0.005, then x minus x1, which is 200. All right, now I will change my variables. This is going to be price again, minus 9 equals, now let's distribute. So we get negative 0.005x, and then negative times negative is positive. And then just to, again, be sure I don't miss a decimal here, 0.005 times 200 should be, 1. So 1. And then go ahead and add 9 to both sides. So add 9 here, and you get price is equal to negative 0.005x plus 10. So this is my price demand equation. And I'm almost done because the very end it says find the equilibrium price per box of oranges and quantity of boxes of oranges in thousands. So what they want to know is what should I set my price at so that the supply is equal to the demand, right? Like in this first scenario here, at this price of $9, my supply and demand are not the same. Here at $8.50, my supply and demand are not the same. What price will give me the same demand and the same supply? Well, that's when we set those two equations equal to one another. So I'm going to take this equation, which says P equals this, right? And I want to know when that same price will equal this. So I'm going to basically set I'm going to say equilibrium price. Okay, to do that, I'm going to take 0.01x plus 5.8 and set it equal to this one, negative 0.005x plus 10. And I'm going to solve this for x. And that, when I solve it for x, x was what is that? X is corresponding demand. Okay, so, well, let's solve for x first and then we'll figure out what it is. Okay, so if I try and get x by itself here, I can add 0.005x here and add 0.005x here. If I do that, it's going to go away here. I'm going to get 0.015x. And then why don't we go ahead and while we're doing that, let's minus 5.8 on this side, or subtract 5.8 on this side. It'll go away over here and we'll get equals, right? Equals. This is going to be 4.2. And then finally to get x, I'm going to divide both sides by 0.015. So 4.2 divided by 0.015, and I get 280. Okay, so let me go back to this picture I had here. I'm going to Draw that. There was a line connecting these two. Then I had erased it. We had another line, which I erased. I don't remember where it was, but I had another line here. And what we just found was this point X. We just found the X. It was 280, where these two lines intersect, which means your price and supply are exactly the same. I mean, sorry, your supply and demand are exactly the same. So this is the supply and the demand. Now remember, it's actually 280,000, right? 280,000 because we were measuring the X in thousands. But what is the price we need to set? We know that there's a certain price where we're going to get the same supply and demand. And that supply and demand will be 280,000, but what is the price? So to get that price, all I have to do now is take this 280,000 and plug it into here for X or here for X. Doesn't matter which one because they both give us the same result, all right? Because we set those equal to each other. So I'm just going to take this one, P equals 0.01, and then X is going to be 280. Be careful, don't put 280,000. 280, and then plus 5.8, like that. And so we get P equals, this is going to be 2.8 when we multiply here, and then plus 5.8. So P is equal to 78.6. Or if you'd like, $8.60. So if we set the price of a box of oranges to $8.60, we will have equilibrium. Our supply and our demand will be the same, and they'll both be 280,000. That's what we're looking for. That's the optimum situation. All right, that is it. I think that's it. Yeah, that is it for the day 2 review.